I'll just say it again. You wasn't listening anyways. So, okay, focus on me. Now we're mixing two things together. Something hot and something cold. This is like red, blue, purple. So all the energy from the red is transferred to the blue, which means the red, the hot, has to be negative. And the blue is going, because it's gaining the heat energy, is going to be positive. There's going to be tons of variables. You're plugging in the Q equals MCS delta T, setting them equal to each other, like being good at 4th grade algebra where you have to like distribute and solve for variables, okay? Okay. Gases. Today is going to be super familiar to you. You've done this before just today. So today is going to be a lot of algebra button pushing. You're just going to kind of remind yourself things about gases. So let's draw high. I'll be there.
I think I should attach a string to my desk, so whenever someone comes to the door, I can just hit that wouldn't work. I got a smart idea.
Okay. When we draw a particular diagram with the solid, we know that we just like make a mound on the bottom of the beaker because the solid is at the bottom of the beaker. When we draw a liquid, we sort of evenly distribute them. We draw our water molecules, we have our dipoles. For when we draw a gas, what we're going to do is we're going to draw molecules with zoomy lines. Zoomy lines show our reader that we know that gas particles are moving really fast and they bounce off the walls of the container and themselves and all over the place. We're doing this. That's how we distinguish between gases and liquids because they're going to fill our picture. Okay? No matter what, gases will fill the container. If we can consider this room a container, there's air at the top of the ceiling and on the floor. They're highly compressible. Yes?
Do we need to draw like the arrows?
The arrows show that they're bouncing, and so yes.
What were you thinking?
Highly compressible means that I can take this whole room full of air and compress it into like a tank. That's what scuba tanks are. If you work in a restaurant, those CO2 tanks that hook up to the soda machines, it's like a room full of carbon dioxide and they squish it into a small container. They're very light and no matter what, I can mix them and they're going to be homogeneous. Homogeneous means that I cannot see the parts. Right now in this room, there's all sorts of gases and I can't tell with my eyeballs that there's anything different. It all looks the same. Okay, take your hand and do this. You can feel gas particles. Now do this. You are pushing gas particles into your face. We cannot see them. We don't really feel them, but when we move them, you can feel them hitting your face, okay? So, when we do gas math,
That's your hands.
don't hit your face.
I don't know. Yeah.
That's a solid hitting a solid. When we do gas math, your temperature has to be in Kelvin. Okay, so to get to Kelvin, we add 273 to our Celsius. Cool, focus, cool. For pressure, our unit most likely will be ATMs, and I have a whole slide on how to convert that and what pressure means. Our volume for gas math is going to be in liters. And then we also need the number of moles, which in our gas equations is a lowercase n for number of moles. This is not Honors Chem, Babies Chem. They're not going to give you moles. So you're going to have to do some stoichiometry. You're going to have to do some converting to get. I know. So, I know. Let's talk about pressure. This is a barometer. This barometer reads the pressure in the room. So right now our pressure is 730, which is way low. Normally, so Germantown's like pretty much at sea level. The pressure is 760 millimeters of mercury. 730 is way low pressure, which means it's cloudy, but it also means it's windy. So if I have low pressure, that means I don't have a lot of gas molecules, particles. And so across the country, all those gas particles that are high pressure are like to an area of low pressure and they move, and that's what we feel as wind. It's the movement of all those gas particles through the gas in the area of low
How does
pressure.
that feel outside though?
It reads the pressure in the room, which is going to be the same as the outside.
It's not going to be different. This isn't a closed off room.
What if we didn't have windows? Would it be different?
No, because we're at the same
What if
level.
when you go into one, you know when you go into one of those.
Dryer.
I'm really good at drawing.
I am too. Look at how good my earth is.
I'm actually not.
I don't think I'm on the right slide.
That's just not right.
This is Russia.
I'm gonna drop it.
Where are we?
Draw yourself on top of the world, because you are.
Yeah, I'm on top of the world. Hey,
Hey.
I'm on top of the world. Hey.
Draw a gazillion gas particles in the atmosphere. It's this many. Oh, and make sure you count them and draw them exactly a gazillion.
Memorize it for the test.
It's on the periodic table test.
Yeah, and we actually have to know the periodic table.
And what a gazillion
You
is.
need to know their charts.
And you need to know your diatomic.
That does not really look like an Earth.
Who's mine? Mine looks exactly like an Earth. What's wrong with you?
Oh, I need a color. Colt?
That's not heavy. I already have one. I asked you if you needed one. See if I got a little less.
Wait, Cole, how would you draw sketch for us?
Okay,
I
so
printed that map to the library.
you would have a string right here. And then you have something down here, like a little hole. Put the string, and then it comes to my desk. And then I would pull it, and it would pull down.
Okay.
It's actually not that hard. Cool, you should make it.
Cool, do it.
Okay.
Or tomorrow.
Who's ever watching this video is going to be so annoyed. Sorry. The atmosphere is full of gas particles. How many gas particles? That are all getting, that one's in your head, getting pulled to the center of the earth because of gravity. Gas, even though they're little and they're far apart, still have a mass to them. Because the gas particles are being pulled to the center of the earth, that is what pressure is. That one's hitting you in the head.
It's because you have gravity.
You have mass, so you want.
There's not that.
E equals mv times 2.
Flat earthers say that gravity is big.
No, that's not true.
And how can a object pull things towards it?
That's strong.
Gravity is
Weather patterns, all of weather has to do with this movement of gas particles in our atmosphere around the earth. So that's how come they can predict it so well, because it's math and it's science. You can just take the density of the air in different locations and predict where it's going to move and what it's going to look like. The only things, there are several things that make it complicated, like big lakes and bodies of water and mountains and things like that, but they're typically very good at predicting because it's just a math model. You can just see where the density is lower is where the gas particles are going to move.
So they know, like, oh yeah, it's like this. If this math works out right,
It has to go there.
Gravity's made up just to make everything in the universe work.
yeah, it's just made up by science.
Okay,
Yes.
our gas math, most likely your temperature needs to be an ATM. Like you can't ever go wrong converting it to ATM. You just don't always have to convert it to ATM. Likely though, you will be given different units. So 1 ATM equals 760 millimeters of mercury. Millimeters of mercury is how they used to measure pressure. So the atmosphere would push down like on a bowl of mercury and it would go up a tube, and then this height they measured in millimeters. Obviously that's not how that barometer works. They don't use mercury anymore. It just still reads in millimeters of mercury. Yeah.
I think we should put mercury on our desk.
No, I did that. I'm gonna get cancer. There was a guy named Evangelista Torricelli. He discovered something. When you discover something, you get to name something after yourself, and so he named a unit of pressure after himself, but it's the same thing as a millimeter of mercury. 101.325 kilopascals. Pascal was another guy who did some things, so he decided to name a unit of pressure after himself. That's equal to 101,325 pascals. And us in the United States, we use PSI, pounds per square inch. We're crazy, because we're different.
I love PSI.
KSI. Who do you think's winning, KSI or
Logan Paul?
Logan Paul.
Logan Paul's.
That's a big
I missed
question.
Oh, there we go.
Technically, it is one learning objective, so they could, but they won't keep it secret. They'll say to the correct answer. I haven't ever seen it though. I think it would.
Don't start this.
Stop me now.
STP. You might remember STP. STP is standard pressure and temperature. Standard temperature is 273 Kelvin. Standard pressure is 1 atm. So if it says it is at STP, this is your temperature and pressure with star. Any gas, it doesn't matter what it is. It could be anything in the whole world. If it's a gas and it's at STP, has a volume of 22.4 liters. It's a shortcut, but only if it's at STP, and if you forget it and you plug in numbers instead, you'll get the same answer. So it's just a matter of
What amount of gas?
any gas. Because oh yes, 1 mole. Sorry, 1 mole of
Alcohol.
there you go.
Does that mean half? 11.2.
That's job full.
Wait, what?
We are going to learn the rest in our sample problems. So go ahead and switch over to sample problems.
Wait, is this here? Why are you drawing pastel?
Cole, this is the 5th unit we've done, and you just asked where the sample problems were.
No, I thought it was this other pattern.
What does that say on the top?
That's not it.
Nobody is going to ask you the name of these laws. It doesn't matter. All you need to know is how they're related to each other. So the first one is pressure and volume. It's an inverse relationship. So when one goes up, the other one goes down. So P1V1 equals P2V2. The units, when you do these relationships, don't matter. Like, you don't have to have it in ATMs for this. It's just going to be the same on both sides. Stop. So a lot of these are going to be reading comprehension. Go through and read them, find out what the numbers are, and then you're plugging them in. So with your bad buddy, go ahead and do this first sample problem. Ready, go. Okay, volume and temperature. Thank you. V1 over T1 equals V2 over T2. Temperature has to be in Kelvin for all of gases. So make sure you convert your temperature to Kelvin. This is a direct relationship. When one goes up, the other goes up. When one goes down, the other goes down. Ready, go. If I keep it less than
Record.
I did. Volume and number of moles. I always have to look. V1 over N1 equals V2 over N2. This makes more sense. If I blow more of my breath into a balloon, the balloon is bigger. More gas particles means more stuff. This is a direct relationship, but you have to be careful for this. This is going to be tricky because the number of moles is never going to just be given to you. You're going to have to convert it. You might have to do some stoichiometry, so we're going to actually do this first part together. Suppose we have 12.2 liter sample containing 0.5 moles of oxygen gas, diatomics. The diatomics are all gases. This whole unit is going to be filled with diatomics. At a pressure of 1 atm and a temperature of 25 degrees Celsius. Keep that in your mind. If all of this was converted to ozone, at the same temperature and pressure, that just told me that I don't need temperature and pressure. If it's staying the same, it's not going in my math, okay? Always going to happen. Tons of extra information. You're not always going to use all the numbers, okay? If it stays the same, it doesn't go in your math. What would the volume be of the ozone? So here is my question. I have 12.2 liters of this and 0.5 moles. I don't have enough information right now to plug into my equation. So first I need to solve for moles over here. So then I have enough information to solve for volume. So we're just going to do a quick mole ratio since I have a balanced equation. You can do a mole ratio to get to the moles and then plug it in. Does that make sense? It's never that simple.
I'm going to start.
Record. P1 V1 over T1 equals P2 V2 over T2. Don't forget your temperature has to be in Kelvin. Okay? So when you have pressure, volume, and temperature changing, you could do things separately and combine them together, or you can just do it all together. Just make sure your temperature is in the correct unit.
Oh, okay. Yeah, we did that. They don't know. I don't know. I always work.
Oh, just kidding.
Having takes